Hello and welcome to this video. In this video, we will be talking about Python programming language. We will see what makes Python one of the most popular programming languages of our times. In this session, we will not be doing any Python coding. We will not talk about Python syntax. We will not talk about any of the Python best practices. We will do that in later videos, but in this video we will just be looking at what is Python and what makes it so popular. Let's start with what is Python. We all know Python is a high-level general purpose programming language, and what makes Python so popular is its simplicity and readability. The Python syntax or grammar looks like English, so anybody taking a look at Python code will be able to understand what that code does pretty easy. Now this is one of the things that makes Python very easy to learn. Now one of the things that we have to keep in mind is though Python is very easy and simple, it is one of the most powerful programming languages available, and that is one of the reasons why Python is used across a wide variety of programming scenarios like data science, automation, web scraping, tooling, prototyping, etc. Another thing to keep in mind when we work with Python is free to use and open source. Python is maintained by the Python Software Foundation, and we don't have to pay any license fee for downloading Python, using Python, or distributing Python. If you want to use Python for programming, we can download Python from the official website, install it, and start using Python. And being open source, we can look at Python's source code and understand how Python works internally, and if there is a need, we can contribute to the Python language by adding features or fixing bugs and make Python a better programming language. Now it's time to look at some of the key features of Python. As I mentioned earlier, Python's key feature is simplicity and readability. The code is very easy to read and write because the Python syntax looks like English. It is very similar to English. We don't have any additional syntax constructs like a semicolon for line ending or a curly brace to group similar or related code. In programming languages, if you're familiar with C++ or Java, we know that a semicolon is required at the end of each line, or a curly brace is required to group related code. So Python doesn't mandate any such constructs. Instead, it relies on indentation based grouping of code. Now that makes Python code very simple and easy to read, and it is very ideal for beginners because we don't have to remember so many keywords to master Python. Just to show this difference, we have these two code blocks. There are two if blocks. One is in a Java syntax and one is in a Python syntax. Both these if conditions are checking for a variable x, whether its value is greater than 10 or not, and if it is greater than 10, we are printing some message onto the console. As you can see, in Java we need a set of parentheses around the condition, we need curly brace to group the lines of code within that if block, and we need a semicolon at the end of the line to mark line ending. And these constructs are not required in Python, where it is simple and straightforward. We just check for the condition, indent the next line into the if block. Indentation is 4 spaces by default. We indent the code, and with that indentation it makes it clear that the print statement, in this case greater than 10, this print statement is within that if block. And this is the simplicity and readability of Python. And there are many other constructs. While we learn Python in detail, we'll come to know, but this is just to highlight at a very high level what is the difference between Python and any other programming language. Now let's look at the next point, which makes Python a popular choice among programmers. Python is having large popularity because of its cross-platform support. What is this cross-platform support? It means that we can write Python in, say, a Windows operating system, and the same Python code we can run on another machine that is running, say, Mac OS or Linux. We don't have to rewrite our code depending on what platform or what operating system we are going to execute the program. We just write the code once and execute it in any platform where we need to execute. So this is something which is very, very important to note, because we write code once and execute in any platform that we need, and this is one of the core thing that makes Python very, very attractive to programmers. How does it work behind the scenes? As you know, Python is an interpreted language. When we say interpreted language, it means that, let's say I write Python code, say 10 lines of code, and I execute that code on my laptop. Let's say I'm using a Windows laptop. I write Python code which is 10 lines and I execute. So when the Python is executed, the Python interpreter picks up my program, execute the first line, and if the first line is successful, it goes to the next line. If that is successful, it goes to the next line, and so on and so forth till the end of my code. So this is what we mean by interpreted language, where each line is executed one after the other. Other programming languages like C++ or any other language like Java, we have to compile the code into a machine understandable format before executing. And once we write the code, we have to compile it, create that machine executable format, which is either a exe or a bytecode, and then that machine executable format code is executed. And that compilation step is not required for interpreted languages. We'll see that in the next slide, but for now we'll understand that whenever we execute a Python code, it is executed one line after the other, and if at all any line of code fails, the execution stops there and we'll get an error message. Alright, now we assume that we have a Python code, and how do we execute? We need a Python interpreter which is specific to the operating system to execute the Python code. For example, if you're using Windows and you want to write Python and execute Python, you have to download Python for Windows in your laptop, write the Python code and execute. Now if I'm using Linux and I need Python in my laptop, I have to install Python for Linux in my laptop and then write Python code and execute. So the Python interpreter that I need will be specific to the operating system that I use. So for Mac OS, there'll be another Python interpreter which is specific to Mac OS. Let's say we write Python code on Windows. In the same Python code I port to my laptop which is running Linux. If I have my translator or Python interpreter for Linux installed in my laptop, I can execute the same Python code without any change. Here the interpreter takes care of executing the code on my system correctly. I don't have to rewrite anything just to make it function correctly in my laptop. This is what we meant by cross-platform support. We'll see this in a little bit detail here. Now at a high level we are comparing Java and Python. This is not a very detailed comparison, but just to understand what or how the cross-platform support works in Java and Python. You're right in assuming that Java is also cross-platform, but there is some difference. Let's try to understand that difference. If I write a code in Java, let's say I'm running a Windows laptop, I have my Java virtual machine installed on my Windows. To execute my Java code, what I need is I have to compile my code into a bytecode, and that bytecode is what is being executed by my JVM. So once I have the code and compile that into a bytecode format, that bytecode can run on any JVM, whether it is Windows or Linux or wherever. So if you are running a Linux laptop having your Java for Linux installed, I can share my bytecode, Java bytecode, and that can be executed in the Linux laptop without any changes. But in case of Python, this intermediate compilation step is not required. I write my code on Windows, I take that program or file that contains my program, I share it with you. You might be running a Linux laptop having a Python interpreter for Linux installed, and you can write the same Python code without any change. So in my case, with respect to Python, I'm not compiling the code into any intermediate format. I'm just working on the same source code file, and that works seamlessly across Linux or Windows or Mac OS, any laptops, any platforms, wherever the corresponding Python interpreter is installed. A lot of people keep comparing programming languages like Python and Java, and this is one of the things that we have to keep in mind. Java is also cross-platform, but Java requires a compilation to bytecode step, whereas Python doesn't require that compilation step. To explain this further, let's consider a simple scenario where we can consider a tourist who can speak only one language, and the tourist wants to visit multiple countries, and each country obviously will have a different language spoken there, but our tourist will just speak one language. He or she doesn't understand any other language. So this tourist, to get things done, he or she will write notes, notes or script, and that script will be carried along with the tourist to the different countries. Now wherever the tourist goes, to get things done, he or she needs a local translator. The local translator will read the script, understand what is required by the tourist, and then perform what is required. So in our case, the tourist is our, say, Python code, and the local translator is the Python interpreter corresponding to that platform, say Windows platform or Linux platform or Mac OS platform. The purpose of the tourist is to get some things done, or the purpose of the program is to get certain things done, say read from a file or write to a file or whatever it is. How the interpreter performs that task is interpreter reads line by line of the script and execute what is mentioned. Wherever the tourist goes, as long as there is a local translator available who can read the script and translate into the native format, things get done seamlessly. We don't have to worry about anything. So this is how we can compare Python code getting executed in different platforms just by the means of a Python interpreted for that platform. And this is the Python philosophy that we keep saying: write once, interpret anywhere. But this depends on the availability of the interpreter or Python for that particular platform. Also, it is important to note that the version of Python is also important. Currently the version of Python is 3. If we have to execute Python code written in Python 3, we need the Python 3 interpreter. We cannot expect Python 3 code to be executed successfully in a platform that contains Python 2 interpreter. So that is very important to note. The version and behavior of the interpreter is essential to successfully execute Python code in different environments. Now the same case, consider Java. Here the tourist needs something to be done. He or she will write it and compiles it into a universal travel guide format. So the tourist is taking an additional effort to compile or convert his needs into a universal travel guide format. And whichever country he or she visits, there will be a country specific reader which will read this universal travel guide and execute or perform whatever is required. So here what the tourist is doing is that, apart from specifying his or her needs, the tourist is taking care of translating that or compiling that into a format which will be read by the country specific readers, and the reader in this case act as a local translator, reading and executing whatever is mentioned in the universal travel guide. Now here the universal travel guide, or whatever we call it, is the Java bytecode. I write my Java code in Windows, I compile it into a bytecode format. Now I take that into a Linux machine where Java for Linux is installed, execute it. Now I don't have to worry about anything because the Java bytecode is something that is understood well by the Java runtime installed on the Linux machine. So this is the difference that I was explaining earlier. In Java case, we write the code once, compile it once, and run anywhere where there is a JVM available. It has that additional compilation step which is not required in Python. Now another feature of Python is the availability of libraries. As I mentioned earlier, Python is open source and community supported, which means that a lot of people contribute to various domains of Python. They write a lot of utility functions or methods and make it available for our use. A library is nothing but a set of pre-written code. When I say pre-written code, it's something like anything for any general purpose. People would have written some code which is made available in a downloadable format. If we need that, we can download it in our code and then use it. Let's say, for example, I want to write a program which reads and writes from Microsoft Excel spreadsheets. Now there are two choices I have. One, I can write my own code to read a Microsoft Excel spreadsheet and write into a Microsoft Excel spreadsheet cell. For this, I need to understand how Microsoft Excel stores the data, what is the data layout, how do I interpret the different sheets, the different rows, the different columns, and then I can do the necessary programming to read and write from the Microsoft Excel. But that is obviously time consuming, tedious, error prone, and it takes a lot of effort to finish that particular functionality. The other option I have is I can go to the Python libraries and see if there are any libraries that are available for us which can perform these actions for us. And there are libraries, several libraries. One such library is this OpenPyXL. I can use that library, which is widely accepted by the community, well tested, and it has a lot of functionalities and available to us free of cost. So we can take that route, use an existing library, and focus on our program's core functionality rather than reinventing the wheel. So this is one of the advantages of working on a community supported programming languages like Python. This saves a lot of time for us, and we can add powerful features into our code instantaneously. We don't have to worry about the data format, or we don't have to worry about how Microsoft Excel stores the data, reads the data, etc. Everything is taken care of by the corresponding library. We just have to find out what is the right library to use, how to integrate that with our program. And this helps in a wide range of ways because we will be focused only on the core functionality of our programs. And Python has support for thousands of libraries. We have several libraries out there like NumPy, Pandas, Django, TensorFlow, etc. Whichever functionality we need, we have to just pick the right library, integrate with our code, and start working. Another thing, this again and again comes back to us. Python is an interpreted language, and I've mentioned that before. The Python interpreter runs our code line by line, and this helps us in a wide variety of ways. For example, we don't have to compile the code into machine language or an intermediate format first. That saves a lot of time. In large programs, it takes a lot of time to compile our source code into a executable format or a Java jar format or whatever it is. Python doesn't need that. We can just write the code, execute it. Since the execution is line by line, or since it's interpreted, we will get immediate feedback whenever an error occurs. Say my program is 15,000 lines and my code fails at the 100th line. The execution stops right there with an error message, so I can take corrective actions immediately, rerun the code, and this helps in having faster development cycles. And this is one of the things which makes Python ideal for prototyping or learning and debugging easier. We don't need that built infrastructure which will compile the code into a binary format and then execute. So I believe we have covered the core features of Python: simplicity and readability, portability or cross-platform support, the support of having a lot of libraries, and Python being an interpreted language. So in the next set of videos we'll see how to install Python, how to run Python code from the console, and in the further videos we'll see how to dig deeper into the Python syntax and write meaningful programs. Thank you very much. Please let me know your feedbacks and comments on the video. I will try my best to correct that and answer your questions. Thank you very much.